Hi, my mathematicians. This week we are doing our unit test, and part of our unit test is we are going to be applying fractions to a recipe. And this is actually a place where you see fractions a lot, is when you're cooking, and you'll see them in recipes for baking and all of those types of things. So if you help your mom and dad with cooking, you might have already seen how you use the fractions. Now, with this one, it's a cake recipe, and let's go ahead and look at it. We have 5/8 cup of flour, 2/6 cup of sugar, 3/4 cup of oil, 9/15 cup of butter, 1/2 cup of water, and 3/9 cup of milk. So we have two questions that we're going to work through. And it might seem overwhelming, but I promise you it is the math that we've been doing, and we just have to break it into little parts. So first of all, when we're looking at this, we're just going to read the question, and then we're going to do the same thing we always do, is we're going to circle the highlighted part, or the important parts. It says, which ingredient does Mrs. Corbin use more of, water or flour? Use greater than, less than, or equal to compare. Okay, so I know I'm trying to see which one is more, and it's water or flour, and they want me to use those. Okay. So I'm going to go ahead and I'm going to go up to my recipe. First, I'm going to look for water. I see water. I have 1/2. And I need flour, 5/8. So this is where, and we want to have it in the middle, and this is where we find our common denominator. So over here, let's go ahead and we look at our denominators. So this, once we get to this point, we know how to do the math. So we've got our 2's, and we've got our 8's, and this is where we do our skip counting. 2, 4, 6, 8. Well, I can stop right there because this one automatically is 8. So remember, we put our times 1, times 2, times 3, times 4. Because remember, we can't compare them unless they have the same denominator. So that's what we're doing now, finding the same denominators. So we have 8 and 8. So from that, we see that this is times 4. This is the 2. So I'm going to do times 4 times 4. And the 8 is just times 1. And remember, if it's times 1, we just bring it down. So we're going to bring that down. And then we multiply. So this is 4 and then 8's. So which one is bigger? Is it the water or the flour? It is the flour. 5/8 flour is more. So did we find out which was more? Yes. Did we use our comparative symbols? Yes, we did. So we are finished with that one. So all it was asking you is which one is bigger. We're comparing. And the big thing to remember is that denominators have to be the same. Okay, so let's look at our next one. I think I need the same amount of 2 different ingredients. So what I'm saying is I think 2 of these are equal. Am I correct? Why or why not? And the thing that stands out to me is same. Same, I remember, is equivalent. So I'm trying to find equivalent fractions up there. Then the next part I can't forget is I have to say why or why not. Can't forget, I can't just give an answer. I've got to say why or why not. Oops, and I forgot the question mark here. So I'm going to go up here, and the first thing that I'm going to look for is patterns. I want to look for patterns because that's going to help me figure out if some of them are equivalent or not. What you can do is you can compare them all to each other and see if any of them are equal. But I'm gonna look for patterns here because that's going to help me out. I notice that 4 and 8, I know that those two, I can compare those two because of the 4 and the 8. So down here, I'm going to do 5/8 and 3/4. And I'm going to say, okay, we've got our 8, we've got our 4's, this is 8, this is 4, 8, this is times 2, times 2, times 2. So I have 5/8 stays the same, and I do 6/8. Are those equivalent? Nope, so it can't be those two. So let me see if there's another pattern that I see. Okay, I see 2 and 4. So let me try 2 and 4 so I can see. So this one is no, and I'm going to try 1/2 and 3/4. Same thing. So I've got to figure out if they're equal or not. It is 2's and the 4's, and I'm going to go 2, 4, and this is 4, so this is times 2, times 2, times 2. This is 2/4 and 3/4. Those are not equal. Okay, now I see 6 and 9. So 6 and 9, I know that are by 3's. So let me go ahead and do those two. So I have 2 6, and I've got 3/9. Now, is this a quick problem to solve? No. Do you have to take your time on it? Yes. And so then I'm going to try. I've got my 6's and I got my 9's. So I've got 6, 12, 18, and 24. Let's do 9. So I've got 9 times 1, 9 times 2, whoops, yeah, 9 times 2, and I see one that is the same. So then I've got my times 1, times 2, times 3, times 1, times 2. Okay, so the 6's is times 3. So I'm going to do times 3, and this one is times 2, times 2. So this one is 6/18. Oh, that one is 6/18. So they are equivalent. So am I correct? Yes. And why or why not? And I would say now let's say 2 6, so yes, 2 6 is equivalent to 3/9. So I'm going to kind of box this one out because that is my answer. So when you get to your problem, it is just taking, this one was comparing fractions. We were comparing, and this one we were doing equivalent. We just had to keep trying the ones until we found one that was equivalent. Now, did I give up after the first one and just say no? No, I had to keep, I looked for patterns where I knew that there was patterns, and I could have even tried the 15th because that's also a factor or a multiple of 3. So when you're looking at this one, where you have to find if they're the same, you're looking for patterns in those denominators. Don't look so much at the numerator, look at the denominator and see if you see any patterns with it.